This is day 7 of ND coding challenge, and today we're going to solve valid anagrams. The inputs for this problem are two strings S and T. You have to check if T is anagram of S or not. Let's take this as an example. For T to be anagram of S, we should be able to rearrange the letters in S so that it can be converted in T. To solve this, we have to keep track of all the alphabets present inside S. For example, we have A, which is number 3. We have N, which is 1. We have G, which is 1. We have R, which is 1. And we have M, which is 1. Now we have to cross check this value for a target. So we have one N. Okay, we have one A, okay, we have an A, okay, we have one G, okay, we have an R, okay, we have an A, okay, we have an M, okay. So you can see the number of different alphabets is exactly matching with the target T. That means S is anagram of T and T is anagram of S. To implement this technique, what we can do is we can use an array. There are other data structures that we can use as well, but array is most search and memory efficient as compared to them. For example, we can use a map, which is search efficient but not memory efficient. We can use linked list, which is memory efficient but not search efficient. But array is balanced in both of these terms, so it's a good choice. Since we're dealing with just lowercase letters, we can create an array of size 26 that can represent each of these letters. And while checking the value of it in S, we can increment the value at same index. After updating, our array would look something like this. We have 3A, 1G, 1M, 1N, and 1R. While traversing T, we can decrement these values accordingly. If in the end, all the values inside the array become 0, that means all the values in S are present in T as well, and our string is anagram. The very first step to check if S and T are anagrams or not, we have to check their length. If their length is not equal, then they're definitely not anagrams. In this step, I'm creating the mem array with size 26. In this for loop, I'm converting every character of S into a compatible index for the mem array. Since we're dealing with only lowercase characters, we can subtract the ASCII value of each character by 97, which is the ASCII value of A, and in return we'll get the index range 0 to 25, compatible with our mem array. For each of those characters, the respective index is incremented by 1. In this for loop, I'm decrementing the index in mem array using the string T. For every character in T, I'm converting it into ASCII index and then decrementing the value for that particular index. In the end, this for loop is checking if all the elements inside the memory are 0 or not. If even any one of the indexes is not 0, then definitely our strings are not anagrams. If the comparison completes, we'll just return true, meaning S and T were anagrams.